If you're watching this, then you're watching my third installment of my rampaging deconstruction of Inspiring Philosophy's videos. While this ongoing YouTube project has been rather fun over the last few weeks, I want to make a more serious statement regarding intellectual honesty and pretending to know things that you clearly do not. Now, don't get me wrong, I'm not asserting that IP, Rods, and others are being deliberately dishonest, but I find it rather strange that they so casually produce material that concerns very, very arcane topics and come to radical conclusions that would put them vastly at odds with the scientific community. Another concern I have is whether or not their subscribers base has any understanding of such topics, or even enough to understand what they are accepting as true. I'm a university student, studying for a degree in electrical and computer engineering with the hope of going into the field of optics and quantum electronics. However, I am by no means a physicist, nor do I pretend to be. And that's the thing. I only speak about things to the extent to which I know them, and after that, I can only refer you to someone else. I know a lot, my friends say, but I don't know everything. When I try to make these videos, I try to make them as accurate as possible and as articulate as possible in order to ensure that I'm actually informing the viewer rather than showering him or her with information concerning something about which the viewer knows little to nothing. If you've been watching IP's videos, there are two words that constantly show up as he tries to argue for his God.
Quantum mechanics, the quantum mechanics, the quantum mechanics. Quantum mechanics, quantum mechanics, quantum mechanics. Quantum mechanics, quantum mechanics, quantum mechanics, quantum mechanics, quantum mechanics, quantum mechanics in 1925.
As I mentioned before, I'm not a physicist. To date, I've taken 2 classes in quantum mechanics, and I am currently taking a graduate level class in semiconductor nanoscale device physics. But I know enough to know that IP hasn't got the faintest clue as to what he's talking about, and this worries me. If there's anything I learned from those previous classes in quantum mechanics, it's that quantum physics is very difficult and very counterintuitive to the way we experience the world. In a way, it frustrates me because it's not necessarily something that a simple layperson can just pick up. It requires fairly large amounts of time and study to understand. What's worse is that the layperson can easily be led astray if trying to achieve an elementary understanding of this topic on the internet, because the internet is a haven for
science and pseudoscience and non-science, junk science, voodoo science, pathological science, bad science, non-science, and plain old nonsense.
While the myriad of refutations of the classical arguments for God's existence are littered throughout the YouTube universe, theistic idealism is something new that has not been addressed. Theistic idealism is just another flavor of the nonsense that I call new woo. IP's video in particularly misrepresent the findings of the field of quantum mechanics, a field, mind you, whose interpretations are not even agreed upon by scientists. One thing I've noticed about the responses to IP's quantum and philosophy videos is that they're noticeably long, and for good reason. This isn't like creationism when you can just refute Kent Hovind's points by thinking for 10 seconds, or even by reading the Answers in Genesis website. This is a field that not only has hotly debated topics still to be sorted out, it is one in which even legitimate physicists have fringe and wacky views. This fact should be a reminder to us skeptics that even smart people can succumb to irrational and unsupported ideas. As of now, I formulated the video in my head, and what I'm looking at is over 30 minutes of refutation as of now. The script for this video will be progressively written so that as I come across a particular point of disagreement, I can write my deconstruction of that point as meaningfully and as articulately as I can. So far, I've received good feedback concerning the explication of my objections to his videos, and I very much appreciate this. So before we delve into the video, I want to make 2 apologies. The first is to those who will have trouble understanding what I'm trying to say. Quantum mechanics can be that way. I'll link everything I can in the description box. If you have any questions, you can put them in the comment sections or private message me. The second is to those whose eyes will glaze over in the first 7 minutes. I apologize. I will try to be as clear as I can, although that will very likely extend the duration of the video. All I'm thinking now as I tackle this massive gish gallop of quantum information pseudoscience is that I hope I haven't bitten off more than I can chew. The video to which I'm responding is entitled Quantum Physics Debunks Materialism. So let's begin. So right away, IP quotes Eugene Wigner, a mathematical physicist known for his contributions to both atomic physics and the development of the principles of symmetry that are applied in elementary particle physics. While Wigner is not a person whom physicists would refer to as a complete quack, as he won the Nobel Prize, toward the end of his life, he became very philosophical and developed an interest in the Vedantic philosophy, an ancient Hindu philosophy that holds that the universe is an all-encompassing consciousness, similar to Brahmanism. This philosophy very likely influenced his interpretation of quantum mechanics, as he saw consciousness as a fundamental necessity to understanding quantum physics. However, this view is neither mainstream nor orthodox.
Materialism was the view of many scientists at the turn of the 20th century. This simplistic view that all that existed was matter and energy, and the rearrangements of it, is the extreme view of realism. Realism is a general belief accepted by many today, that a physical reality exists independent of observation, and roughly 100 years ago, most held to one of these two views, rejecting the opposing view, idealism, the view that reality is a mental construct, and doesn't exist independent of observation. For many back then, their understanding of physics seemed to favor this side of the spectrum, firmly believing it buried idealism. However, this realistic worldview was shaken with the advent of quantum mechanics. The realization of how the quantum world behaved began to eat away at the materialist and realist beliefs. Matter was thought to be tiny particles that existed independent of our observation. However, the equations of quantum mechanics and the results of the double slit experiment changed that. To understand what this experiment showed, a simple explanation is given. Subatomic particles were thought to exist like tiny bits of matter, not like continuous waves of energy. However, sending electrons through a double slit showed they acted like waves of energy instead of tiny bits of matter. Even sending one electron through at a time, the same results happened. However, when one set up a measuring device at one slit, the results changed, and the electrons acted as one would expect, as tiny bits and not spread out waves.
When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently, as though it was aware it was being watched.
While IP did describe the double slit experiment fairly for the most part, the part on which many people get lost is what is meant by an observer. You see, as a matter of physics, it cannot be a human observer, as our eyes are not sensitive enough to see the low-intensity light that is frequently dealt with in these types of experiments. Moreover, the wavelengths used are far from visible. You have to understand that IP relies on these fringe science quacks to produce these videos. His Dr. Quantum videos are produced by physicist Fred Alan Wolf. Wolf is a fringe physicist whose quantum consciousness ideas have been featured in both The Secret and What the Bleep Do We Know, just to give you a matter of perspective. Unlike IP, I will actually tell you what is meant by an observer in regards to this experiment. You see, the classical picture of light is as a continuous wave that moves in the air, or in a vacuum. On the classical picture, when light passes through a slit, it forms cylindrical waves, and then it passes through two narrow slits and disperses into an interference pattern on the screen. Here are two clips explaining the concept with water waves.
This spreading out of a wave as it passes through an aperture is known as diffraction, and it's a property of all types of waves. So what do you think controls how much the wave spreads out? Well, one possibility is the width of the aperture. And what do you think would happen if I made the aperture smaller? Well, you might be surprised to learn that a narrower aperture leads to more spreading out of the wave, more diffraction. If instead I make the aperture wider, then after it's settled down, you can see that the wave becomes less spread out. The diffraction is less pronounced. And if I were to make the aperture very wide indeed, then there'd be hardly any diffraction. To demonstrate diffraction with light waves, I need to use much smaller apertures. I also need to use a different light source, one with a very narrow beam and a very narrow range of wavelengths. And in order to achieve that, I'll be using this laser beam, and of course I'll be taking care not to look directly into the beam. Now this slide contains the apertures I'll be using, and in fact the first one is just 60 micrometers wide, or 60 microns for short. That's about 1/16 of a millimeter. So if I place this slide in front of the laser beam, you'll see the diffraction pattern on the screen over there. The aperture is aligned vertically, and that sharp spot of light has clearly been spread out or diffracted in a horizontal direction by the small aperture. You can see that the diffraction pattern consists of a series of dark and bright regions spaced regularly either side of the center. The image appears bright in regions of so-called constructive interference, where light waves from different parts of the aperture combine to reinforce each other, and dark in regions of destructive interference, where light waves combine in such a way that they cancel each other out. The double-headed arrow indicates the width of the central bright region. This spreading of the laser beam shows that light does indeed propagate like a wave. Now, if you remember with the water waves, you saw that changing the aperture changed the amount of diffraction. So again here, if I use a smaller aperture, you should see that the diffraction pattern spreads out more. This next aperture is just 30 microns wide. Again, the double-headed arrow indicates the separation of the first dark regions on each side of the center. And if I swap again to an aperture that's 120 microns wide, you can see that the diffraction pattern becomes less spread out.
Well, if light were behaving as particles, you would expect them to go through each slit and just produce a bright spot underneath. So we would see two bright spots on the bottom of the box. But if light's behaving as waves, then the wave from one slit can interact with the waves from the other slit. I've got a demonstration here on a little pond where we can see this with water waves. I have two sources of ripples, which are basically like the two slits. When I create ripples with a single source, they travel out with circular wavefronts. Nothing particularly surprising there. But if I add a second source of ripples, then we start getting an interesting pattern. This pattern is created by the ripples from the two sources interacting with each other. Where they meet up peaks with peaks and troughs with troughs, the amplitude of the wave is increased. That's what we call constructive interference. But if the peak from one wave meets up with the trough from the other, then we get destructive interference and there's basically no wave there. And this is exactly what was happening with the light.
So you get the idea. However, it does get interesting when one discusses the act of observation, and here's usually where people are led astray. Now understand that the classical picture of light still manifests itself even when dealing with just one single photon at a time, which was puzzling to physicists, so they decided to make an observation. In these types of experiments, observation is done by a detector, usually in the form of a photomultiplier tube, not a human being. A photomultiplier is a class of vacuum tube that is made to detect very low intensity ranges of the electromagnetic spectrum. The photodetector must interact with the photon in order to know the slit through which it went. The first stage of the interaction is when the photon collides with the photocathode material. Through the photoelectric effect, this collision produces electrons that are then multiplied by a process known as secondary electron emission. During the process